So angle J is congruent to angle P, and then we have to find out information to use AA about one of the other two angles. I used N for me to find out just because it had more space for me to show. So when we're trying to figure out the measure of this angle, we have to use the fact that we have 180 for our total sum of the interior, and then subtract the angles we know. Well, 180 minus 90 brings me to 90, right? So 90 minus 55 might be a quicker way for me to do that math without my calculator. So what is 90 minus 55? 35. So now do we have another pair of congruent angles? We do, right? Angle K is congruent to angle N. And therefore, we can now say by AA, triangle, I'm going to start with, I'll go with my right angle, JKL, is similar to triangle PNM. Over here, we look at this, and we do not know what our angle measures here are. We show that they're congruent marks. We can look at this if we know those two angles are congruent. And then we have the 72 and 38. You might be able to look at this and see what's going to happen. But if you can't, I like to choose a very specific example. So we just have to have two congruent angles that would make sense in here. In my last class, I just said, what if those congruent angles were 30 degrees? I'm not saying that they are for sure. Let's say they were, and we're going to look at it. So if we wanted to find this angle measure, and we have two congruent angles, we just picked a random 30 degrees, we could do 180 minus 30 minus 38. So that gives me 180 minus 68, so 112, double check my math. Okay, and then this one down here would be 180 minus 30 minus 72, which would be 180 minus 102, which would give me 78 degrees. So when we look at this, would any other pair of angles be congruent? No. So we'd say these are not similar.
You just pick a random number?
So that is one way of looking at it. So you could reason it out knowing these would be the same, that there would really not be an option for the other one. But yeah, that's how I normally look at it. Is I pick a specific example and I look at it. Sometimes I pick two just to make sure. But we know it's not going to work out.
What's
Yes.
the highest extra credit thing in this class?
So our next one up, we see we have these triangles. You have two triangles kind of in one. So our first part is going to show two congruent angles. Do we have two? Well, do we have two congruent angles?
Yes.
Yes, we do. Which one are they? We actually know something about all of the angles in this one. What do we know about this angle up here? It's an angle, and it's in both triangles, so therefore it is congruent. We also know that we have parallel lines being cut by a transversal. Parallel lines being cut by a transversal, which means this is the property you had to use on your last quiz. These are corresponding angles, so therefore they're congruent. So we're able to use the fact that the sides are going to be proportional. So when I do this, I'm going to start with the smaller triangle. I have 10 in my numerator. And then I'm going to put my other numerator in because it also corresponds with the smaller triangle. So I put my 10 and 12. Well, which side corresponds to the 10 in the bigger triangle?
The X.
Yep, the X. And this is the part where I feel like it could get a little confusing, so I'll make sure you guys are careful. What is the side length that corresponds to the 12 in the bigger triangle?
The 6.
So the 6 corresponds, but it's actually going to be the whole length because the 6 is added to the 12. So be careful there when you guys do these, which would give you 6 plus 12, 18. So just make sure you guys don't fall into that trap because we're going to be using it a lot today. So when you're at this point, we're able to do our cross multiply. So 10 times 18 is 180. 12 times x is, we're going to divide by x equals 15. Okay, so here we're doing 7.4. We're showing triangles are similar using side, 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 and side, angle, side. Your objective today is to show that two triangles are similar using side, 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 and side, angle, side similarity theorems. Okay, so here you guys don't have to write anything. This is side, side, side similarity theorem. So if you have corresponding sides in two triangles that are going to be proportional, then the triangles are similar. So instead of just showing the two angles are congruent or all the angles are congruent and all the sides are proportional, all you have to do is show all of the sides are proportional. And so here, only thing I put on mine was I underlined it, corresponding sides are proportional. You're going to tell me to determine whether these triangles are similar. If they are, we're going to write a similarity statement to find that triangle B. We didn't have a label here, so we're going to call this one A. We're going to call this one B. So scale factor of triangle B to triangle A. So that means that B is going on top and A is going on bottom. So we write this out. B over A is what we're looking for when we write it that way. We're looking first to see if we know enough to show it by all the sides are proportional and all the angles are congruent. We don't. We don't have enough information to show angle. So since we just learned about side, that's probably where we're going to go. So I'm going to write out it in letter form first. So Q, P. So I'm starting here, Q, P. And that means it's going to be over ST. And then I'm going to work my way around. So the next one's going to be QR over TU. And my last one's going to be RQ. Sorry. RQ over US. Oh, you were correct. Thank you. RP. Whew, that was a close one. Thanks, Taylor. Okay, so from there, we now get to substitute in what we have. QP is how much? And ST is 4. After that, we have QR, which is, and then we have TU, which is, and then we have PR, which is, and then we have us, which is 6. So our next part of this is now going to reduce these to see if we have the same ratio. So what goes into 8 and 4? 4 goes into 8 how many times?
2.
Goes into 4 how many times? 1. What goes into 5 into 10? 5 goes into 10 how many times?
2.
5.
1.
What goes into 12 and to 6?
2.
Okay. And?
2.
Yeah.
You wrote 6.
I did. I wrote 6. Woo! This is a fun day. Okay, 2 and 1. Okay, so do we have the same ratio? So ratio is 2 over 1. But that's not what it asks for. It wants a similarity statement, so we're going to write triangle. And then again, it's okay how you write this. It can be start with S, T, or U. None of that matters. As long as you match it up to the angle that's going to be congruent to. This is where people struggled on the quiz. So we want to have S. That's just where I picked S, T, U. And that's going to be similar, not congruent, similar to triangle PQR. So we have AB, and then that's going to be proportional, if it is, to the similar side, which is XY. And then we go BC, which goes to YZ. And then from there we have CA, which goes to ZX. AB is how much? 15. XY is? BC is? YZ is? CA is? And then we have last but not least? 12. So now we're going to go through and we're going to see if we have enough information to see if the ratios are similar. So what goes into 15 into 10? How many times does 5 go into 15?
3.
How many times does it go into 10?
2.
What goes into 12 and to 8?
4.
How many times does 8 go into, or 4 go into 12?
3.
How many times does it go into 8?
2.
Okay, what goes into 18 into 12?
6.
How many times does it go into 18?
3.
How many times does it go into 12?
2.
So by side, I've really missed the opportunity to sing that to you guys all last semester. We can now say that triangle, again, it doesn't matter which one you're starting with as long as you match up the angles that correspond. ABC is similar to triangle XYZ. So our next one up, you see you have 2 triangles here. Let's do our triangle, this one to be on top. So we're going to start with LM, and it goes over PQ. And then we go MN, and that goes over QR. And then our last part would be NL over RP. So what is your value for LM? What's your value for PQ? What's your value for MN? What's your value for QR? What's your value for NL?
15.
And what's the last one?
13.
Thank you. And you're looking at this, and right now you're already waving a uh-oh flag, right? Something's wrong. What's happening?
We got a 9 and a 5.
We got a 9 and a 5. And what's happening in the first one? 12 over 12 reduces to what? 1. So 1 over 1. Can I ever reduce 9 over 5 to 1?
You can make it a type of fraction.
We can make it a mixed number, but that's not going to do us any good. We see we can't get them down any further. They're never going to be the same ratio. So we say these are what? Not similar. So you have the side angle side similarity theorem. So if you have an angle in one triangle that is congruent to an angle in a second triangle, and that the lengths of the sides that include the angle are going to be proportional, then they're going to be similar. So if we were going to do an example with what they have here, that would be these angles, X and M. And I don't really have a good way of showing this because I don't want to use a congruent mark. And I don't know of a mark that I could use to show that they're just similar sides. So what I did in my last class is I just used the similar symbol to show that they weren't really congruent. So we had MP similar to XZ, and we have MN similar, I'll do 2, to YX. And you see here that when you have your fingers onto the sides, when they meet together, they meet at that included angle, the angle directly between the sides. You go the other direction, you end up with 2 different angles. Those are not included. So make sure you remember that. So what I have here is I put included angle and then proportional sides. So, okay, so we see here we have an angle. Only one pair of angles that we know. Are they congruent? Yes. So I'm going to show that real quick. We have angle C is congruent to angle F because we know that 61 degrees is equal to 61 degrees. So we already have the fact that the angles are congruent shown. The other part is going to be the sides that make that an included angle. So that would be the 2 sides that form the sides of that angle. So we're going to do AC first. So AC, which is going to be over DF. And then on our other one, it's going to be CB, which is over FE. What is the distance of AC? What's the distance of DF? Okay, what's CB? And what is EF? Okay, 5 over 3 is already in its lowest form. But what about 6 over 10?
3 over 5.
You can go 10. I mean, not 10.
You can divide by 2.
You can divide by 2, so we get 3 over 5. So we see our ratio is going to be 3 over 5, or 3/5. And so now we have an include. So now that we have all those parts, we can now say triangle. And again, as long as the angles that are going to be congruent match up, you're going to be fine. Angle ABC is similar to triangle DEF by side angle side. Okay, so our first part here is you see you have 2 triangles. You have a small triangle, and if you get rid of this middle line, you see you have a big triangle. Sometimes that can be confusing, so I kind of recommend that you guys draw 2 triangles off to the side so you guys can see them. So we have W, V, X, and I know this side is 4 and 5. And then over here we have V, Z, Y. And I'm going to try to look at both of those pictures to form what I'm going to be doing. So our first part is we want to look and see if we have an angle that we know is congruent in both triangles. It's helpful to look at the original picture for this one. Do we know of any angle that's congruent in both triangles?
Yes.
Yes, what is it?
W. Wait. You said the A?
V and
Yep.
V.
So we know that's going to be V and V. And if we knew they were parallel, you'd be correct. But since we don't know these lines are parallel. But yeah, V is in both triangles. It's in the top angle for both of them, and they're going to be the same measure. So we're going to have angle V is congruent to angle V. We don't have to show that they're equal because we already know what we don't know what the value is. And then we're going to talk about the sides. So we have VW.
What is that?
I don't know, but it's loud.
Oh, I hope it ain't no.
So we have VW over VY, and then we have VX over VZ. We know the top ones, which are going to be 4 and 5. But we've got to figure out the length of VY. How long is the whole length of VY? 8 and 4, right? So 8 plus 4 is 12. On this side, it's going to be the whole length of VZ, which is 5, and 10, which is 15. So we have 12 over 15. We're going to see if we have a similar ratio or the same ratio. What goes into both 4 and to 12? 4 goes into 4 how many times? How many times does it go into 12?
3.
What goes into 5 into 15?
5.
How many times does it go into 15?
3.
So we end up with a ratio of 1/3. So by side angle side, we know that triangle WVX is similar to triangle YV, that's a Y, YVZ. And again, I just started here. We know that these two angles would have to be the same, so they're going to be congruent, and then I worked my way around. That way you see how I'm naming it. Okay, so I'm going to start by drawing the triangles, and then you're going to fill those in, okay? So we have our two smaller triangles. We have LM, that's a 4. So LMQ, 14, 16. And then we have our bigger triangle, which is going to be LPN. And then we know the side lengths here. What's going to be 16 plus 40? 16, 56, thank you. And then what is 14 plus 35? 49. Way to go, guys. Okay, you ready? So what are my ratios in letters?
LQ.
Over.
LP.
Yep. And what's my other one?
LM.
LM over.
LN.
Perfect. Do you want to fill in the numbers as well?
No.
Okay, who would like to tell me the numbers that go into these?
LQ is 14.
LQ is 14. Okay, over.
49.
49. Perfect. And then LM
16.
over.
56.
Nice job, guys. Okay, so our next one is now to look to see if there's anything in common between 14 and 49. 7. How many times does 7 go into 14?
2.
2. How many times does it go into 49?
7.
Okay, what goes into 16 and 58 or 56? 8. How many times does 8 go into 16?
2.
How many times does it go into 56?
7.
Okay, so we know our ratio is?
2 to 7.
Yeah, 2 over 7. Okay, with this, we can now write that these triangles, LMQ, is similar to triangle LNP. By side angle side, SAS. We're going to see if we have a pair of congruent angles, do we? Yep, which ones are they?
H and M.
H is congruent, yep, to angle M. Okay, and then we have to talk about the two sides that form that angle. So that would be GH over LM. And then we have HJ over MN. What is the distance of GH? What's LM? Okay, what is HJ over 8? We're going to see what we have in common here. What goes into 8 and 2, 6? So that goes into this 4 times. This goes into this 3 times. What goes into 12 and 8? 4. How many times does 4 go into 12?
3.
How many times does it go into 8?
2.
Okay, do those ratios match?
No.
Nope. Therefore, not similar.